Thank you for purchasing this continuing education training course from PDH Pro. We provide high-quality online education for engineers and other professionals. The title of this training course is Compressed Gas Safety. This presentation has been specifically developed for employees who work with compressed gases as part of their job duties. Please make sure you are in a comfortable setting and able to concentrate as we work our way through this presentation. You will receive 1 hour of credit for successfully completing this course. At the conclusion of this presentation, you must take the quiz and correctly answer at least 70% of the questions to receive your certificate of completion. We have very specific learning objectives for you during this presentation. At the conclusion of this course, you will understand various types of gases stored within compressed gas cylinders. Recognize the chemicals and physical hazards associated with these gases. Be familiar with work practices for the safe use of compressed gases in the workplace. Our presentation today will cover the following topics. We will review information about compressed gases and cylinders. We will then review both chemical hazards and physical hazards. We will discuss some of your responsibilities. A gas cylinder or tank is a pressure vessel used to store gases at high pressure. Gas cylinders are typically constructed of carbon steel, stainless steel, aluminum, or composite materials. Gas cylinders come in many sizes, depending on the application and whether the cylinder is to be portable or in a fixed location. A standard portable industrial gas cylinder is 57 inches tall, 9 inches in diameter, has a wall thickness of about 1/4 inch, weighs about 155 pounds when filled, and contains 330 cubic feet of gas at a pressure of 2,640 pounds per square inch. Of course, there are many other sizes of portable cylinders, all the way down to the propane cylinder for a camp stove you can hold in your hand. There are 4 different types of compressed gases stored in gas cylinders. They are as follows. 1. A substance that remains a gas at standard temperature but increased pressure. 2. A substance that liquefies at standard temperature but increased pressure. 3. A substance that is dissolved in a solvent. 4. A substance that is liquefied at reduced temperature and increased pressure. We will review each type in the following slides. The first category of compressed gases includes those substances that remain a gas at standard temperature and increased pressure. Examples of these gases include air, argon, helium, nitrogen, oxygen. The second category includes substances that are liquids at increased pressure and standard temperature. Examples of these compounds include butane, propane, carbon dioxide, nitrous oxide. The third category includes substances that are dissolved in a solvent at standard temperature. The most common example of this type is acetylene. Note, acetylene cylinders contain an inert packaging material and are filled with a solvent such as acetone. The acetylene is pumped into the cylinder and it dissolves in a solvent. When the cylinder is opened, the acetylene comes back out of the solution, much like a carbonated beverage bubbles when opened. The fourth category includes substances that are liquefied at reduced temperature and increased pressure. These are also referred to as cryogenic gases. Examples of cryogenic gases are liquid nitrogen, liquid oxygen, carbon dioxide. Note, cryogenic gases are typically equipped with some type of bleed device to prevent overpressure from rupturing the bottle and to allow evaporative cooling to continue. There are 2 types of hazards associated with the use, storage, and handling of compressed gas cylinders. The chemical hazard associated with the cylinder contents, such as corrosive, toxic, or flammable. The physical hazards, represented by the presence of a high-pressure vessel in the work area. In the next sections of this presentation, we'll explore these hazard categories in greater detail. In this section, we'll review chemical hazards associated with compressed gases. Depending on the particular gas involved, there is a potential for exposure to considerable chemical hazards. Gases used may be flammable or combustible, corrosive, explosive, poisonous, inert, acidic, reactive, and a combination of hazards. Care must be taken to avoid exposure to these gases through inhalation. Extremely toxic gases should only be used inside ventilated hoods or outside with sufficient ventilation. To avoid any confusion and to ensure safe handling, the specific contents of all compressed gas cylinders needs to be clearly identified. Identification of the cylinder contents can be accomplished by stenciling or stamping the contents on the cylinder or on the label. Commercially available 3-part tag systems are convenient for identification and inventory. Never rely on the color of the cylinder for identification. Color coding is not reliable because cylinder colors may vary with supplier. Also, never rely on labels on cylinder caps because they are interchangeable. Inspections should be periodically performed to ensure that the contents of all cylinders in the workplace are clear and identified. Of course, all compressed gases need to be included in the Hazard Communication Chemical Inventory and Material Safety Data Sheets, or MSDS, available in the workplace. In the workspace, compressed gases should be segregated from the following: high traffic areas, oil and grease, flames, sparks, or any source of heat or ignition, electrical circuits. Cylinders should be protected from the ground to prevent bottom corrosion, direct sunlight, continuous dampness, salt or other corrosives. Many gases, including a variety of organic compounds such as ethylene, propane, or methane, are flammable and can turn a cylinder into a flamethrower if ignited. Flammable gases can be ignited by static electricity or by a heat source such as a flame or hot object. Flammable gases should not be stored near unprotected electrical connections, heat sources, or any source of ignition. Cylinders containing flammable gases, empty or full, should be separated from cylinders containing oxidizing gases by a minimum distance of 20 feet or by a barrier of at least 5 feet high, which has a fire-resistant rating of at least 1/2 hour, for example, a concrete block wall. Storage of flammable gases in a ventilated, fire-resistant enclosure is recommended. If this is not possible, flammable gas cylinders should be stored in a well-ventilated space. The use of flow restrictors or surge protectors on flammable gas cylinders is recommended in order to prevent a sudden large flow of gas if a rupture or other unexpected release happens in the system. Leaking cylinders constitute a threat that may be so serious that entire facilities may be required to evacuate and outside help may be required to assist. Leak detection procedures should be implemented prior to use of any system using compressed gas. This can be accomplished in the following manner. For a flammable gas detector, a soapy water solution, or a 50% glycerin water solution may be used. At temperatures at or above freezing, the 50% glycerin water solution should be used. For systems where toxic or corrosive gases will be used, first, test the system with an inert gas before introduction of the hazardous material. Emergency procedures should be established and communicated to all personnel so that everyone knows what to do in the event of a leaking cylinder. Engineering controls are the most effective method to control the risks associated with compressed gas use. Common engineering controls include the following. An emergency shutoff switch can be used at a remote location to cause pneumatic valves to shut, stopping gas flow. Switches should be non-electric so that the arcs or sparks are not created around flammable gases. Hazardous gas cylinders can be housed in a gas cylinder cabinet, which can be equipped with sprinkler protection and ventilation. Flow restrictors can be used to limit gas flow and should be installed immediately downstream of each hazardous gas cylinder. An emergency eye wash must be present in areas where corrosive materials or gas is used. Welcome to Section 3, where we will review the control of physical hazards associated with compressed gas cylinder usage. The principal physical hazard associated with compressed gases is the rapid release of contents under pressure if the container were to rupture. The container may rupture due to contact, such as a forklift puncturing a propane tank, or a portable cylinder may be knocked over and the valve stem cracked as a result of hitting the floor. Of course, once an uncontrolled release of contents occurs, we've got some serious potential problems. It has been reported that if a full tank were to have the valve sheared off, the projectile could travel some 500 yards and go through concrete walls. Other problems may shortly follow based on the nature of the gas being released. The gas may create a toxic or flammable atmosphere, for example. Gas cylinders must be secured at all times to prevent tipping. The cylinders should be secured in a vertical position. The cylinders must be secured at a point approximately 2/3 of its height, using an appropriate material such as a chain, plastic-coated wire cable, or commercially available cylinder straps. Cylinders should be secured individually, meaning one restraint per cylinder. The issue with restraining multiple cylinders on one restraint is that in order to move one of the cylinders, all of them must be unrestrained. There are some very important rules to follow when transporting compressed gas cylinders. Never drag, slide, or roll a cylinder. Use a cylinder cart or basket. Always have the protective cap covering the valve when transporting the cylinder. Never transport the cylinder with the regulator in place. Make sure the cylinder is secured in the cart before moving it. Do not drop cylinders or strike them against each other or against other surfaces violently. Do not use the valve cover to lift cylinders. They could be damaged and become unattached. Ropes or slings should not be used to suspend cylinders unless the gas vendor has made provisions for such lifting and attachment points are provided on the cylinder. There are a variety of tests that may be performed on various cylinders. Some of the most common types of tests are the hydrostatic test and the burst test. During the manufacturing process, vital information is usually stamped or permanently marked on the cylinder. This information usually includes the type of cylinder, the working or service pressure, the serial number, date of manufacture, the manufacturer's registered code, and sometimes the test pressure. High-pressure cylinders that are used multiple times, as most are hydrostatically or ultrasonically tested and visually examined every few years. In the U.S., hydrostatic or ultrasonic testing is required either every 5 years or every 10 years, depending on cylinder and its service. When gases are supplied in gas cylinders, the cylinders have a stop angle valve at the end on top. During storage, transportation, and handling when the gas is not in use, a cap may be screwed over the protruding valve to protect it from damage or breaking off in case the cylinder were to fall over. Instead of a cap, some cylinders have some sort of protective frame around the stop valve. When the gas in the cylinder is ready to be used, the cap is taken off and a pressure regulating assembly is attached to the stop valve. This attachment typically has a pressure regulator with upstream inlet and downstream outlet pressure gases and a further downstream needle valve and outlet connection. The upstream pressure gauge indicates how much gas is left in the cylinder according to pressure. The regulator could be adjusted to control the flow of gas out of the cylinder according to pressure shown by the downstream gauge. The outlet connection is attached to whatever needs the gas supply, such as a laboratory instrument, for example. The following guidelines apply to gas lines and hoses. All gas lines leading from a compressed gas supply should be clearly labeled to identify the gas and the area served. Hoses should be examined on a regular inspection schedule. Unnecessarily long hoses should be avoided. Keep hoses free from kinks and away from high-traffic areas. Repair leaks promptly and properly. Do not use a single hose for multiple types of gases. Before cylinders are first used, the following precautions should be taken. Make sure the cylinder is equipped with the correct regulator. Inspect the regulator and cylinder valves for grease, oil, dirt, and solvent. Never use grease or oil to lubricate regulators or cylinder valves because they can cause an explosion. The cylinder should be placed so that the valve handle at the top is easily accessible. When using toxic or irritating gas, the valve should only be opened while the cylinder is in a working fume hood. Only use wrenches or tools that are provided by the cylinder supplier to open or close a valve. Pliers should never be used to open a cylinder valve. Some regulators require washers. This should be checked before the regulator is fitted. Refer to MSDS for the gas being used for information regarding use and toxicity. Now, fire extinguishing equipment should be readily available when combustible materials can be exposed to welding or cutting operations using compressed cylinder gases. Open the valve slowly and only with the proper regulator in place. Stand with the cylinder between yourself and the regulator, cylinder valve outlet facing away when operating the cylinder valve. The compressed gas storage area should be free from risk, away from sources of heat and ignition, designated as a no smoking area, clearly marked as a gas storage area with appropriate hazard warning signs, kept clear with access restricted to authorized personnel, provided with appropriate safety and emergency equipment, including a fire extinguisher and adequate ventilation. Compressed gas containers placed in the storage area should be capped, stood upright, and properly secured with approved cylinder support. Segregated according to their various categories, such as flammable, oxidant, etc., and providing 20 feet between incompatible gases. Segregated in the storage area according to whether cylinders are full or empty. Managed to ensure that the oldest stock is used first. Checked periodically for general condition. All cylinders are to be considered full unless properly identified as empty by the user. In many workplaces, the user writes the letter M and T, the phonetic spelling of empty, on an empty cylinder. In other workplaces, tags are used. Empty cylinders should be returned to the supplier and not be permitted to accumulate. To prevent contamination and even explosive mixtures in cylinders, always leave at least 25 psig minimum pressure in all empty cylinders. Do not leave an empty cylinder attached to a pressurized system. Let's review some of your responsibilities as a user of compressed gases. As a user of compressed gases, you should know the content of each cylinder you use. Ensure regulator is proper type, valves, and hoses are in good shape. Follow rules we have discussed for storage, transportation, and use of cylinders. Know what to do in the event of an emergency. Here are some outstanding sources of additional information on this important topic for your future reference. Compressed gas safety. General Safety Guidelines, published by the Montana Department of Labor and Industry. Air Products Safety Grams are a series of technical pamphlets published by Air Products. The Compressed Gas Association, CGA, publishes standards and specifications for the compressed gases in cylinders. Compressed Gases Self-Inspection Checklist, published by the National Institute for Occupational Safety and Health. Congratulations! You have completed the training portion of this course, Compressed Gas Safety. If you wish, you may repeat this presentation to review the course material and to prepare for your exam. If you have not already downloaded the handouts, you should do this next and review all the materials. Once you're confident that you have mastered the topics presented in this course, you should take the quiz. You must answer at least 70% of the questions correctly to pass the exam. After you complete the exam, you'll receive your certificate of completion. This certificate will be available in your account in the completed courses section.